Hi everybody and welcome to IMVC 2021. I'm Lawrence Moroney and I lead AI advocacy at Google, and my focus is on making it as easy as possible for people from all walks of life, from hobbyists to developers to researchers, to be able to understand the possibilities with AI and to get you access to materials where you can explore whatever it is you want to do with machine learning. So today I'd like to begin by talking a little about the TensorFlow ecosystem. It's been almost 6 years since we open sourced TensorFlow to accelerate machine learning research and to empower developers around the world to build AI applications. Since then, TensorFlow has expanded into a vast ecosystem of tools and frameworks that will help you along in your AI journey. Our community has also seen an incredible growth. TensorFlow alone has crossed over 200 million downloads. Our tutorials and guides have been read over 56 million times. Our blog posts have 10 million reads, and our YouTube channel recently crossed 12.5 million views of our videos. And I'm also excited to announce that with our MOOC courses globally, we've actually passed the 1 million learners mark. We're really proud of our wonderful community, so on behalf of our whole team, I do want to say a huge thank you to you all. But I'd like to share some updates of some of the things that we've been working on, so let's get started. 18 months ago, we released TensorFlow 2.0, and it was a whole new API that was designed to be easier to use, easier to scale, and aimed to deploy everywhere. Since then, we've been hard at work to improve TensorFlow 2. We've been listening to your feedback, adding new features, but also focusing on stability and performance. And what's particularly exciting to me is that TensorFlow 2 powers cutting-edge research, and it brings it to real hands-on APIs that developers can use without needing deep domain expertise. And this to me is the true power of a platform like TensorFlow. We've also recently released version 2.6, and this includes pre-processing layers that make it easier for you to do data pre-processing directly in your model architecture, so things such as image augmentation are made much simpler. On the topic of Keras, we've invested a whole lot in it as our high-level API. And we've been working on making it really easy for you to get started building powerful models with simple coding building blocks. The sequential API is very easy to use, and you can see here how you can stack layers of a neural network with just a few lines of code. But Keras isn't limited to this. It can also help you with more advanced modeling tasks. So indeed, as your journey progresses, you may find you need more exotic networks, or you may want to chain different networks together. Like here, I'm showing a generative adversarial network. The Keras functional API is designed to let you implement these advanced use cases using the same coding skills that you had with the Layers API. But of course, Keras is not the only way to use TensorFlow. In research, for example, we've heard that many users prefer to directly use NumPy. So we've built NumPy into TensorFlow. It's presently experimental and would love your feedback on it. But the goal here is to combine the simplicity of the NumPy API with the power of TensorFlow, so you can take advantage of GPU and TPU acceleration, and all of this is possible in a free web tool like Colab. And as I mentioned, TensorFlow is an ecosystem, with its goal to make ML easier at every stage, from creating models to analyzing models and then deploying them to a variety of runtimes. And you'll do this with tools that span the entire developer lifecycle, from creation to deployment. But we also want to keep responsible AI front and center and have all of this powered and driven by the needs of the community. So let's now take a look at the first part of all of this, and that's where you create models. Generally, if you're creating models, there's a life cycle that you go through. You might want to reuse existing work. You might want to check for existing models in a repository like TensorFlow Hub. You'll also need to work with data, which is, of course, the lifeblood of any AI system, and we have tools that are designed to help you discover existing data sets or easily manage the ones that you already have. Tooling is important, and of course, we want to give you the best of breed tools for training all sizes of model. And when it comes to training, we've been investing heavily in Keras as the easiest way to build models. And this is important because most of us don't get it right the first time, and we'll need to tweak, optimize, and continually tune our code. So let's look at some of the new things that we've been working on in this space, starting with discovery. Often you want to get started with building models, and the first question you might have is there existing work that you can reuse? The goal of TensorFlow Hub is to give you a repository of over 10,000 pre-trained models that you can reuse and that you can build on and extend. And as well as discovering models, it gives you the ability to test your models in the browser without building anything yourself. So for example, here's a vision model that recognizes different species of birds. With the new improvements we made in TensorFlow Hub, you can test your model simply by dragging and dropping a picture directly in the browser. So if I do this, it will tell me that this bird really is a bald eagle. So you can learn more about TensorFlow on tfhub.dev. Now that we've chosen a model, let's take a closer look at our data. Understanding your data is a critical step in building a model. It's also central in identifying potential sources of bias. To help you do that, we're excited to announce this new dataset exploration tool that we've been working on called Know Your Data, or KYD. Know Your Data is a web-based tool that helps you understand rich datasets such as those containing images and text, and seamlessly explore them to spot potential biases or imbalances as part of your regular workflow. So for example, when creating my online courses, I made a dataset using synthetic CGI images of humans, and my explicit goal was to avoid bias by having a variety of different skin tones, different shapes, multiple genders, all of those kind of things. But without realizing it, many of the images in my dataset, particularly where people had darker skin tones, were not actually recognizable. Computer vision models couldn't see their faces. But this tool helped me discover that. And I'd love to see what type of things you can discover in your data where you may be unintentionally introducing bias or other issues to your models. And I'll share some more responsible AI tools a little bit later in this talk. Okay, so we have our model, we understand our data. Next thing we want to do is to start training. Training a model often needs you to take the same steps, loading your data, defining your features and your labels and all those kind of things. But what if those steps could be automated? And with that in mind, we built TensorFlow Lite Model Maker. The goal here is to simplify the process of training or retraining a model using your custom data by automating these common steps. Typically, if you want to do transfer learning, and that is to use somebody else's model and then retrain it on your own data set, there are multiple steps involved. And this can translate into a lot of code, which you might not be familiar with if you're not a data scientist, and difficult to maintain even if you are. With Model Maker, all you need is just a few lines of code like this. This example shows how you can train a comment classifier model on your own data based in CSV. The model can then be used in TensorFlow Lite on mobile or TensorFlow JS in the browser, or of course served via your enterprise with TensorFlow Serving. Now this is a text model, but we've also made other model types such as audio classification, image classification, and advanced text models like BERT easier for you to use using Model Maker, and it goes all the way down to easy integration in Android, iOS, or in the browser. So we often start training on a local machine, but at some point it's important to be able to scale, and this can be a complex process. But what if you could do this from your own user interface, whether Colab, Kaggle kernel, or indeed your local terminal? TensorFlow Cloud was created with all of this in mind. With TensorFlow Cloud, you can send your training job to run on a scalable cloud infrastructure without ever leaving your terminal. It works as a Python package that provides APIs for a seamless transition from local debugging to distributed training and hyperparameter tuning using Google Cloud. I'll show you how easy it is to use. Here's a code sample for a simple image classification model based on CFAR data. You'll usually use keras model.compile and model.fit to train this model in your regular notebook environment. But now let's say you want to run this code on a much larger dataset. To have your code train on cloud, you simply add a couple of lines of code like this, and voila! Your code trains seamlessly on the scalable Cloud AI platform. Now let's say you want to distribute your training across many accelerators to get to your results faster. For this, all you have to do is choose your accelerator configuration and number of workers and your distribution strategy over 10 T4 GPUs, and it's automatically set for you. That's pretty cool, right? You can get started today by visiting our GitHub site for step-by-step examples. But building your model is just the first step. So let's now take a look at analyzing and optimizing models, and we'll start with model analysis. And this means we're understanding why a model behaves the way that it does, and also how it can perform better. We have a suite of tools that help developers do analysis of models, and TensorBoard is a visualization toolkit that lets you understand experiments. It lets you do things like tracking metrics, visualizing the model, exploring model parameters, embeddings, and a whole lot more. TensorFlow Profiler is designed to profile the execution of your TensorFlow code. And both of these I find are super helpful tools, and they can offer up a host of useful information to you. Let's move on now to optimization. The Model Optimization Toolkit is a suite of tools and techniques that are used to optimize models to run smaller and faster, using techniques such as quantization and pruning. Note that these techniques are often really important when the models are running on devices with constrained capabilities, such as mobile phones. And here are some benchmarking results for these tools, where we explored the relationship between the impact on the model size and the accuracy cost. So for example, when using quantization-aware training, we were able to reduce some model sizes up to 75% with minimal accuracy loss. And as you can see here, we get some pretty great gains in size reduction with a very small accuracy loss with some of these techniques. And we're continuing to make improvements in increasing the set of models that are supported. Check out our YouTube channel for talks on this topic, where you can learn a lot more. Another useful feature that I want to call out is for performance tooling, and this helps you benchmark and improve mobile performance. TensorFlow Lite now includes built-in support for systrace, and it does integrate seamlessly with Perfetto in Android Studio. After analysis and optimization, it's now time to think about deployment. And deployment can be on mobile phones, servers, browsers, and a whole lot more. I'd like to talk about server deployment in a little bit, but first let's walk through what it takes to put models onto phones and other devices. The number of edge devices continues to increase, and they're becoming more powerful, and we've seen a ton of innovative features using ML on the edge being built. That said, we work with a diverse set of developers, some of whom are just starting out, and they need off-the-shelf solutions. And there are other developers who are far more sophisticated. Their hardware also needs to vary greatly, from the latest powerful phones all the way down to tiny microcontrollers. So our goal with TensorFlow Lite is to have an open source ML framework for on-device inference. It's used widely for powering on-device machine learning in Google's apps, and as well as being used for powering popular external apps, to the extent that it's actually used on more than 4 billion devices. With TensorFlow Lite Micro, we then have the capability to reach hundreds of billions of microcontrollers and embedded systems. MLKit makes it easy for mobile developers to use on-device ML in their apps to cover common use cases, and it's used in many apps and has about 500 million active monthly users. And then there's TensorFlow JS, and this is a library for machine learning in JavaScript, which allows developers to deploy ML to browsers and Node.js backends or things like Electron apps. It has pretty robust growth at about 3x year over year, and we've seen the NPM package installed over 3 million times, while the CDN has had over 50 million hits. With TensorFlow Lite, we're continuing to work on making performance better. We want to make conversion easier, and we also want to improve the ease of use via high-level task libraries and APIs. In addition, one other thing that we're working on is on-device training capabilities, and we'll be talking a lot more about that soon. We're also adding the TensorFlow Lite runtime to Google Play services, so now you don't need to bundle it with your app. And of course, that means no additional APK size increase, as well as you don't need to manage and monitor different versions of the runtime itself. Google Play Services does that for you. MLKit, if you want to deploy turnkey models, allows you to do that. But if you've built your custom models, you can also deploy them quickly and easily. And they've got this lovely high-level programming API based on Firebase. And speaking of Firebase, Firebase hosting lets you host your models, and that allows you to do easy deployment and updating them without bundling them in your app, as well as being able to do things like experiments, A/B testing, that type of thing. There's a whole lot there, understand. So if you're interested in trying out the new feature of TensorFlow Lite bundled with Play services, you can sign up for an early access program, and we hope to launch it fully soon. Earlier I mentioned MLKit, and one of the things is it offers a wide range of ready-to-use APIs for vision and natural language, and it runs on both Android and iOS. We've worked really hard to make it easy to use, and the APIs are built on top of our own best-in-class models and pipelines, many of which actually power our own apps, so you can use those models directly. Moving on to browsers, developers can use TensorFlow.js to deploy ML to the web, and we're making it even easier to do so by integrating it with TF Lite. So if you've created models and you've converted them to the TF Lite format, you're no longer restricted to mobile and native mobile apps. You can run them in browsers on feature phones, you can run them on any browser, or you can even run them in Electron apps. So that's one of the nice things I really like about this, is that developers can now reuse your solutions for mobile without having to rewrite for the web. And even better, it allows us to reuse a lot of the optimizations that we've been working, that I spoke about earlier, that are built into TensorFlow Lite models, so that you can have better on-device performance. And finally, of course, there's TensorFlow Lite for microcontrollers. And with deployment and microcontroller advancement, there's a whole new world of opportunities waiting to be explored. TensorFlow Lite for microcontrollers is designed to run ML models on these devices that can maybe only have a few kilobytes of memory. We believe that ML on microcontrollers and embedded systems has huge transformative potential, and with this in mind, we partnered with Harvard University to widen access to education around it and to make it accessible to all developers. And one fun project that we've been working on together with Harvard and the Navajo Technical University is to recognize the Navajo language on microcontrollers using machine learning. So I can speak words like yaate, which is Navajo for hello, and I hope I pronounced it correctly, or ahe, meaning thank you, and a microcontroller can actually understand me thanks to the power of ML on these tiny devices. So to put it all together, using our tools, developers can now deploy machine learning to smartphones, feature phones with browsers, microcontrollers, and embedded systems. And I also want to call out the Coral project, which is designed to help developers at both development and deployment time around accelerating their machine learning models, and we're continuing to release new dev boards all the time. At Google, we provide several offerings in the space of on-device machine learning to serve developers with different levels of familiarity with ML, as well as their diverse deployment needs. However, navigating all of these options can be sometimes difficult and confusing, so we've launched a new on-device ML site to help you navigate all of the different options, be it turnkey, be it custom models, from cross-platform to mobile to in-browser to micro and all of these things. We've also launched some new learning pathways on that site designed to teach you end-to-end using videos, code, and code labs how to build apps using common machine learning scenarios, computer vision, audio processing, natural language processing, and a whole lot more. Let me walk you through an example learning journey. For example, you might have a site that sells dresses, and you want customers to be able to use your app to take a photo of a dress and match that to one that's in your inventory. So then when they take a photo, the model will recognize all of the dresses in that picture. And then when they touch on the dress in the image, the app will cut out that part of the picture, send it to your site, and perform an image search for dresses that match the selected one. The search results can then be made available to your users right in the app where they actually took the same picture. And this is a pretty complex use case because it involves orchestrating an ML model on the front end in the app and a product search API on the back end with a whole bunch of glue code. If a developer was building this on their own, it would typically be their job to integrate it all and probably to make it work on both Android and iOS. So we've built a learning path to help with that scenario and many others. Please check out the site. Would love to get some feedback from you on it. For those of you working on enterprise problems, you likely know that there's a whole lot more which goes into building and managing production setups for machine learning. You'll be creating all kinds of models, and both those that run on the server side and those that run on devices. You're doing deployment along with using tools to do data validation, model analysis, performance measurement, and a whole lot more. So to serve that need, we've built TensorFlow Extended, or TFX. And after a beta, we've actually just announced this year that TensorFlow Extended TFX 1.0 is ready for production ML at enterprise scale. TFX 1.0 goes beyond TensorFlow to include other frameworks that you might want to use for training. And it includes all the things that a production framework generally needs, like enterprise-grade support, security patches, bug fixes, and guaranteed backwards compatibility. It also has a stable release cadence, So along with strong support for running on Google Cloud and support for mobile, web, and NLP applications. You can learn more about TFX 1.0 on this website. There's a lot of great stuff in there to get you started, including tutorials, our user guide, and of course our API reference docs. We're always so impressed by what you can all build using our AI tools, so I wanted to take a moment to share this case study with you. The Trevor Project is the world's largest suicide prevention and crisis intervention organization for LGBTQ young people. Now, they partnered with Google.org fellows to create a crisis contact simulator, and this is an AI-powered counselor training tool that simulates digital conversations with LGBTQ youth who may be in crisis. Using this simulator, they expect to train almost 3,000 new digital counselors, reaching these young people on the mobile platform that is their preferred mode of communication. And it's applications like this one, where AI is used to open up whole new scenarios that weren't previously feasible, that particularly excite me. Now, we've covered a lot of ground today in talking about creating, analyzing, optimizing, and deploying models, but there is an important part of the developer lifecycle that spans across all of these. And that is keeping responsible AI top of mind in everything that you do when building AI and ML solutions. I mentioned the Know Your Data tool earlier, but there's also many other tools to help you integrate responsible AI practices into your machine learning workflow. Things like fairness indicators, and these generate metrics for transparency reporting to help you make better decisions about how to deploy your models responsibly. This tool is part of the TensorFlow model analysis component, and this lets you evaluate model performance sliced across different groups of users and let you dive deep into individual slices so that you can explore root causes and maybe opportunities for improvement. Also, the Model Card Toolkit library streamlines and automates generation of model cards. And these are documents that provide context and transparency into your model's development and, of course, its performance. Integrating the Model Card Toolkit into your ML pipeline will allow you to share your model's metadata and metrics with researchers, developers, and users to help them make more informed decisions. We always recommend a people-centric approach to AI, and to help with this, we've recently launched the People Plus AI Guidebook version 2. This update is designed to help you put the guidance into practice with new resources, including code, design patterns, and a whole lot more. The goal, to help you focus on your user as you design your AI solutions. And finally, I would love to talk about the most important part of what we're building, and that's our community. Since we launched TensorFlow, you've organized special interest groups, you've contributed to our open source projects, you've shared your models and your data with one another, and the community as a whole has benefited as a result. And this past year, we've had to find ways to connect through virtual events around the world, and we ran things such as the TensorFlow Everywhere series. We love connecting with our community, and we can't wait until we can all get back together on the road to do some in-person workshops and events, and I hope to be able to come and visit you all in person next year. Until then, we want to help you all to connect better with one another. To help with that, we've just launched the new TensorFlow Forum to promote dialogue and to give you a platform to share ideas, inspiration, and best practices. So please come on over and join us at discuss.tensorflow.org. We've also invested a lot in education, and I'm extremely proud to see that we've passed the 1 million learners mark. You can visit the Learn ML page on tensorflow.org to explore books, courses, and videos that will help you improve your knowledge of machine learning and learn how to apply ML to your own projects using TensorFlow. When you're ready to showcase your proficiency in building models, you can also take our certificate exam. We launched this a little over a year ago, and since then we've had more than 4,500 developers from over 80 countries take the test, pass it, and get certified. You can share your expertise with the world by then displaying your certificate on LinkedIn, GitHub, or of course the TensorFlow Certificate Network. We've been hearing great feedback, including some life-changing stories around this, and I'd like to tell a little bit about my friend Fran here. Now, Fran lost her job during the pandemic, and she helped to boost her resume using the TensorFlow certificate. She got hired by Google, and she's now a conversational AI engineer at our offices in Australia. If you haven't already taken the exam, I encourage you to review the skills checklist on tensorflow.org/certificate to see if this is right for you, and it may help you continue your journey as an ML developer. And don't forget, we do have a stipend program where you can apply for a reduced exam fee as well as a scholarship that accesses the training materials for free. Another question we often get is, how do we get started with the community, or how do we meet people to start projects? Well, one of the first things you can do is reach out to the GDEs, and we love our network of GDEs. They give tech talks, organize workshops, organize doc sprints, and so many other things. And they're the folks who are the boots on the ground near where you are to help you get started. Another great way is to join a TensorFlow user group. We have about 140 user groups spanning 33 countries, so go check them out today. There's so many ways that you can connect, learn, and contribute. So thank you all again for helping to build our wonderful ML and AI community with TensorFlow. At the end of the day, we provide the tools so that you can build and have an impact on the world. And with that, I'd like to say thank you so much, Toda Rabah, and I hope you really enjoy the rest of this conference. Please feel free to reach out to me with any questions you might have. My Twitter handle is right here. Thanks again.